Hello, today I want to help you get started with 2D kinematics. Now the first question is probably the most important because it relates to the ideas of the most common question type. This is pretty much the same stuff as you've done before, except you're given an initial velocity at an angle. And so all you really have to do is take that velocity. In this case, we've got some red ball launched from level ground with initial velocity of 28 meters per second, 40 degrees above the horizontal, and we just want to know how high it is in the air 2 seconds later. So we're going to make a little triangle, and we're going to break into components like we've done previously. So this is 40 degrees. And if we're interested in how high above the ground it is, not how far sideways it's gone, really we only care about the vertical component. We could solve for both, but really we're just going to need the vertical. So that's all I'm going to solve for. This would be our like VIY, like our initial y velocity, would just be 28 times sine 40. Remember the whole like opposite divided by hypotenuse equals sine 40. So if you rearrange that and solve for opposite, this is what you'll get. And that's just going to equal 18. So that's the initially how fast up you were going, or this ball was going. And so then remember, you can't mix vertical and horizontal information. So what we're going to do is just do kind of like d equals VIT plus 1/2 AT squared. To find out how high we are above the ground, we started off at 0 height above the ground. We were initially going 18 meters per second up. By the way, I am making up positive and down negative. So yeah, after this, it's just like equations you've already done, just like 1D kinematics. The only additional step was this whole finding whichever components you need. And then after we've done that, we will never use this again. We only care about the components. Treat them, yeah, like the components are the important part for the solving. And so then we'll just plug it into the formula. It's 2 seconds later, and then plus 1/2. We'll make it negative 9.8 because we made down negative, times 2 squared. 18 times 2 is 36. 1/2 of 4 is 2. 2 times 9.8 is 19.6. So we got negative 19.6, which will give us, we're basically subtracting 20 here with rounding. So it's basically going to be 16 meters, 16.4, but it will round to 16. So hopefully that makes sense. Again, big key idea. The only main difference we've got is we've got initial velocity at an angle, and we just got to draw our little triangle and find whichever components we need to solve the problem. In this case, we just needed the vertical because we're interested in the vertical height above the ground. 2 seconds later. So that is a very common question type. And basically all I want you to learn from this is if you've got initial velocity at an angle, your first step is basically always to draw a little triangle with it, find the components, and then just use the components. I never want to see this like 28 degrees in a formula for something like this. And next question, we've got an aircraft flying due west. Sometime later it's flying due north. Which vector best represents the aircraft's change in velocity? Now, remember, you can kind of pretend it's displacement. So here's like your 0 moment. So we're looking for change in. So notice I'm not drawing these tip to tail because we're not adding them. We're saying, hey, we started off going west. We ended up going north. How do we get from the start to the end? Bam, done. Notice we are adding our initial to our change in. This is our change in velocity. This is our VI. These two get added to make our final velocity. So we are doing tip to tail, but only the ones that are being added. Initial plus change in equals final. So these two get added to make that. But yeah, I just like doing the logic thing. Hey, this is where I started out. I can pretend any vector is displacement. So I'm saying I start here, I end at this point. This is how I get there. And that's going to be my change. So answer is A. If you prefer kind of like the more mathy way, like the whole change in velocity is always VF minus VI, because change in anything is always final minus initial, that would be my final vector minus my initial vector. And if you're subtracting a vector, you're basically adding the opposite of it. So that's the same as plus this. And if you want to add vectors, you just draw them tip to tail. And so we can do this. And here's our final. There's our change in. That's our change in F. If we draw our, this is final plus initial. I should maybe draw this in a different color. And so from the first tail to the last tip, we get the change in. Except it is freezing on me, so apologies. All right, there we go. Working again. Beautiful. All right, so that's how you do that one, using either kind of logic. Hey, we started here and ended there. What's kind of vector takes us from here to there? Or we can just do final minus initial. And subtracting is the same as adding the opposite. And adding vectors, you just draw them tip to tail. And then your result of that adding is just from the first tail to the last tip of vector. All right, next one. This one's pretty basic. Which of the following contains two vectors? Time is scalar, distance is scalar, so that's not it. These are not the ones that we are looking for. Time is a scalar. It's not got a direction. So many seconds north doesn't make sense. Distance is, again, a scalar. That is the scalar version of displacement, kind of your run distance or whatever. And then, but these guys, though, these are both vectors. Velocity is vector, acceleration is vector. So that is our answer. And here's another quick and dirty one. Sort of thing doesn't come up much, but hopefully you remember from last time. We want to know the total distance traveled by the car during its motion. In this case, distance will be the same as displacement because it didn't change direction. So nice and easy. We basically have a triangle and a rectangle. Hopefully you know for any graph ever, if your y variable, your average y times your x is something useful, the area under the graph is that thing. So in this case, average velocity times time is displacement. So area under a VT graph is displacement. So hopefully you just remember that. We got a triangle here we can solve for. Looks like it's got a height of 9 and a base of 5. 9 times 5 is 45. Divided by 2, we've got 22.5. And then we've got our rectangle here. So just base times height. So it looks like we got a base of 10 and a height of 9. 10 times 9 is 90. 90 plus 22.5 would be 112.5, which rounded for sig figs gives us 110. So yeah, just a quick recap from the last unit, which you are not allowed to forget. Now the last common question type is adding vectors. But in this case, we're not doing it kind of to just find the general direction. We actually want to find an answer. So you did practice on that with the like little package you had before. So same deal. If we've got an airplane heading due east relative to the air, and the air is moving so fast relative to the ground, we want to find the speed of the airplane relative to the ground. And to do that, we just add these two vectors, like the speed of the airplane relative to the air, added to the speed of the air relative to the ground will give us the speed of the airplane relative to the ground. Think about that for a while until it makes sense. Anyway, so the actual mechanics of how we do this is we can either do it with components or the cosine law. I'd probably recommend cosine law, but I'll do a little component example here quick just to do it. If we do 65 times cos 45, we are going to get 46. And if we do 65 times sine 45, we will also get 46. So we've got our southward and westward components of our wind. And then we'll just basically come up with a new triangle with our total north-south and our total east-west. So our total kind of east-west is 215 for this guy, minus the 46 west for the wind. And so 215 minus 46 would be 169 to the east. And our only south one is 46 south. So then we can just draw a triangle where we've got 169 east and 46 south. And then we can find the hypotenuse with Pythagoras. So our velocity of the plane relative to the ground is just going to be 169 squared plus 46 squared, all square rooted. So if we plug that into our handy duty calculator, we would get 175. And you might be like, what? There is no 175 on here. But if you adjust for sig figs, given that this has only 2 sig figs, you'll find it does in fact round to 180. Now that is one possible solution. The other possible solution, and probably the way I would do it, though this isn't bad, is cosine law. And in that case, you just got to draw your 2 vectors tip to tail. So we got our 215. So this whole business was how to solve it, and we've already solved for it using components. And this is how we'll solve it using the cosine law, if you've hit that in math. So 45 degrees and 65 here. And then our resultant vector is going to be from the first tail to the last tip. So this is our V plane and the ground. And we're just set because, fortunately, we've got kind of our side angle side sandwich, and anytime we have that, we can just find the opposite side using cosine law. Cosine law is as it is on your formula sheet, c squared equals a squared plus b squared minus 2a times b times cosine of the angle opposite the side you're looking for. This is the angle opposite the side we're looking for. So we're just going to plug her in. We're going to say, hey, our V plane relative to the ground is equal to, I'm just going to make 215a just for fun. Doesn't matter. It's commutative. Plus 65 squared. By the way, commutative just means order doesn't matter, because 65 squared plus 215 squared is the same as 215 squared plus 65 squared. Same with the multiplication. So it doesn't matter which one you decide is A and which one you decide is B. Just pick one. All right, so continuing. So minus 2 times 215 times 65 times cosine of 45. And take the square root of all that delightfulness. Anyway, once you plug that into your calculator, which I'm sure will be a joy, I'm going to wager you get about 175, because it's exactly the same question with exactly the same answer. And that's just how you do it. Notice though this formula is pretty ugly, once you got a side, angle side kind of sandwich, it kind of You're just plugging in numbers and throw it in your calculator and you're done, which is kind of nice. So that's how you do it. Two options, either using components or cosine law. Either way, you are effectively adding two vectors to find the result. So you get questions like this that are like airspeed, wind speed to find the speed of the airplane relative to the ground. You've got kind of boat questions where a boat's traveling on a river and you've got the speed of the boat relative to the water and the speed of the water relative to the shore. Same thing. You could do it with a conveyor belt, but those are the types of questions that will be like this. Anyway, hopefully you found this helpful. I'm going to go teach you now.